Good morning. So CATEE is traditionally an energy and efficiency conference, as we all know. But in the last few years, we've added water to the equation, and you've already heard a little bit about it this morning. And it's a very important thing to start adding to our energy discussions, because energy and water are both basic components of economic progress and components of life, and they're inextricably linked. We use energy to secure, deliver, treat, and distribute water, and we use water to, and often degrade that water, to develop, process, and deliver energy. The energy-water nexus is also a cascading problem that we see, especially here in Texas, where if you have drought conditions that exist, there may be limited water for cooling power plants, and therefore there's reduced power to move that water. Further, demand for air conditioning spikes during hot and dry days, which increases the demand for power, which increases the demand for water, and you see how this cycle just continues and continues. So they are inextricably linked, and so we should start talking about them as the same thing. They're so impacted by each other. Estimates of water-related energy use range from 4 to 13% of the nation's electricity generation, but regional differences can be very significant. For example, in California, 19% of the state's electricity consumption is used for pumping, treating, collecting, and discharging water and wastewater across the state. Energy consumption by public drinking water and wastewater utilities, which are primarily owned and operated by local governments, as many of you know, can represent up to 40% of a municipality's energy bill. And a lot of times there's a lack of awareness because of the levels engaged in those utilities, who the operators are, who the planners are. They're all different and not maybe exactly aware of the amount of energy that's being used for treating that water. At many wastewater treatment plants, energy can be the second highest budget item after labor costs. It's pretty significant. Each year, Texas uses an estimated 2.1 to 2.7 terawatt hours of electricity for water systems and 1.1 to 2.2 terawatt hours for wastewater systems, which is the equivalent to the electricity for 100,000 people for a year. That's pretty significant. Across the nation, as well as in Texas, 90% roughly of our energy comes from nuclear and fossil fuel power plants. They require nationwide 190 billion gallons of water per day, or 39% of all US freshwater withdrawals. Of that 39%, only about 3% is consumed, and while that seems like a small number, energy generation is usually in very localized areas where the water use is in competition with other users such as cities or agriculture and ecosystems. And as the contest for water heats up, there's no guarantee that power is going to come out a winner. Excuse me. In the commercial and industrial and institutional sectors, which is what we're going to talk about in a second here, potential water savings through energy efficiency and other measures could be 15 to 30% without reducing the services derived for water, just through using energy efficiency measures. In the 2014 Carbon Disclosure Project Water Disclosure Global Report, conducted on behalf of 573 investors with assets of $60 trillion across the world, they reported 68% of those responding companies to their water disclosure survey said that water is a substantial risk to their businesses, but only 42% have publicly demonstrated a commitment to water. Water cannot be viewed through a carbon lens, so we can't look at it the same way we look at reducing our GHG or carbon emissions, because unlike carbon emissions, water is not fungible. One unit of water is not equal to another unit of water withdrawn in an arid urban environment versus a wet rural environment. They have completely different impacts, completely different associated risks. And in order to address these fundamental risks, companies have to move quickly to move beyond just water accounting, and they need to conduct some comprehensive water impacts and rate assessments. Thank you. Allergies, sorry. Well, Austin too. I just drove up from Austin. So one company that we love to, we're going to hear from in a second here, that's done a really remarkable job at really considering those impacts of water on their business plan, their business model, is AT&T. A quarter of water used in a typical large office building flows through cooling towers, and buildings with data center use even more water for cooling. So every time you go online, every time you send an email, that creates heat in the data center, which uses water from the power plant. So it's all connected. A couple of years ago, AT&T reached out to EDF to work together managing water use and risk, and we saw an opportunity to get our feet wet, pun intended, in corporate water use. We've been working for years in agricultural water use and in the energy-water nexus, but this was an exciting opportunity to team up with a leading company, plus a great way to build on our experience working on energy efficiency in commercial buildings through our EDF Climate Core program, where we embed graduate students in companies to find energy efficiency savings. So today, we're going to hear from AT&T about our partnership and let you hear firsthand the AT&T perspective on working with EDF. We have with us today John Schultz, who is the Director of Sustainability Operations at AT&T, focused on embedding sustainability into AT&T's operations, products, and services. John focuses on integrating sustainability into operational resource use, energy, greenhouse gas emissions, and water. The services and products that AT&T brings to the market. So he's focused on the sustainability component of those. John has held a wide range of positions at AT&T, including time spent with the sustainability, external affairs, energy, corporate real estate, and IT organizations. He received his MBA from UT and his BA from Trinity, and he is LEED certified as well. So welcome, John.